Hi guys, today I'm going to go through the first two work problems on the 30s. So if you're following along on your 30s in the gases unit, I'm going to show how to do these two problems. They're very similar to the 25s, your homework from yesterday. The only difference is that now we're going to be introducing the moles and how the number of moles will affect different gases. So let's read this first one. At 111 degrees Celsius, ammonia as a gas has a pressure of 888.88 millimeters of mercury. If the pressure is changed to 222.22 and the number of moles of ammonia is doubled from 12 to 24, what's the new temperature? Okay, so you can set up a data table if you'd prefer to. You can set up a data table for the three variables. In this problem, we have temperature, we have pressure, and we have moles. Okay, there's nothing about volume, so we don't really have to worry about that in this one. I'm going to skip the data table for right now. Okay, but one of our rules says that when we set up these problems, we want to set them up with the variable that we only have one number for. So if we look back at these numbers, we only have one number for temperature, and they're asking us to find a new temperature. So we're going to start with our temp. However, we can't use the Celsius temperature. We have to switch that to Kelvin. So let's switch that first. So if I have 111.0 degrees Celsius, I need to add my 273.15 to switch that to Kelvin. So when I do that, you should get 384.2. We go down to just one decimal place because we're using adding and subtracting sig figs. So the 111.0 is to the tenths place. The 273.15 is to the hundredths place. Our answer can only go to the least precise of those two, so we go to the tenths place. Okay, so now we can start our problem. We're going to start with the 384.2 Kelvin. And we're going to set up our next factor. It doesn't really matter whether we select pressure or we select moles for the next unit. What does matter is that we have our labels be the same and that we set it up in the correct order. So I'm going to start with pressure. Okay, pressure in this problem is in millimeters of mercury, so I'm going to write that as both my label for the top and the bottom. Okay, and then underneath that factor we have to think about how that's going to affect the temperature. So the temperature is what we started with, so we're really interested in how the pressure changes our temp. So P in this problem is going down. We're going from 888.88 all the way down to 222.22. So pressure is going down. What does that do to temperature? Temperature and pressure are directly related, so temperature must also be going down. Based upon that, the fact that we need our temperature to go down, we've got to set up this factor so that it actually mathematically does go down. So we want the larger number for pressure in our denominator to make that temperature get smaller. So I'm going to put the 222.22 up top, and I'm going to put the 888.88 on the bottom. The next factor is for moles. So we're going to set up that fraction bar, and we're going to use the label of moles on top, moles on bottom. Okay, same thing, we've got to do the arrows. So we're switching moles, which is little n, and we're trying to figure out how that affects the temperature. We're still referencing the original 384.2 at the start of our problem. So our moles is going from 12 to 24. That sounds like it's getting bigger. If moles gets larger, what does that do to our temperature? This is that weird relationship. This is an inverse relationship between moles and temp, and it's a mathematical relationship. It's difficult to think about and have that make sense, but I can tell you that it is going to be inverse, so this is actually going to force our temperature to go down. So, again, we want to set up our fractions so that mathematically this actually does make our temperature get smaller. So we want the bigger number in the denominator once again. So we're going to put 12.0 on top and 24.0 on the bottom. Now we're all set up and we can solve it. Okay? So we're going to take the 384.2 Kelvin, multiply it by the 222, divide it by the 888, multiply by 12, divide by 24, and I'm getting a final Kelvin temperature with 3 sig figs equal to 48.0 Kelvin. Now in this problem, they don't want us to just leave it in Kelvin, they want us to switch it. It says find the new temperature in Kelvin and convert it back to Celsius. So when we switch from Celsius to Kelvin, we add 273. If we're switching from Kelvin back to Celsius, we just subtract the 273. So let's take our 48.0 Kelvin and let's subtract 273.15 to get this back into Celsius. When you do that, you should get a negative 225.2. Once again, we're using adding, subtracting, sig fig rules. So the Kelvin temperature that we had was the 48.0. That goes to the 10th place. The negative 273.15 goes to the 100th place, so our answer can only go to the 10th place. Let's try the next one. Same thing, we're going to be looking at how the moles affects different gases. So in this one, we've got a sample of radon. It occupies a space of 1,250 milliliters at 61.111 degrees Celsius. We're going to have to switch that to Kelvin in just a little bit. If the temperature is lowered down to negative 12.001 Celsius, and the pressure goes up from 444 to 333, what would the new volume of the radon gas be? So we're solving for volume. Okay? So we must have to start this problem with the original volume that they gave us in the problem, which is a 1250. Okay? Before we do that, let's switch our Celsius temperatures into Kelvin and use those to make sure that we don't screw up the math. So let's take the 61.111 degrees Celsius and let's add our 273.15. When we do that, we should get 334.26 Kelvin for the first temperature. The final temperature is a negative 12.001 degrees Celsius. Once again, we're going to add the 273.15. When we do that, we should get 261.15 Kelvin. So now we've got our right values for the Kelvin temperature to use in the problem. So let's start the problem. We're going to start with the volume. That's the variable that we only have one number for. So we're going to start with 1250. We'll set up a fraction bar. Once again, it doesn't really matter which one we select. We've got a temperature change. We've got a pressure change. So it doesn't matter whether we select the temperature or the pressure first. I'm going to do temperature. That came first in the problem, so I'll do that. So as my temperature goes down, how does that affect my volume? If temperature goes down, volume also goes down. That's a direct relationship. So if I want my volume, that 1250 that I started with, to get smaller, I must have to put the bigger value of temperature in the denominator and the smaller one in the numerator. So I'm going to put the 334.26 Kelvin in the bottom, and I'm going to put the 261.15 Kelvin up top. I need one more factor because I also have a change in pressure. So I'm going to switch from, it looks like a higher pressure down to a lower pressure. So for my variables underneath, pressure looks like it's getting smaller. If pressure goes down, that makes the volume actually go up. They are inverse. So now I want my larger number on top. I want this to get bigger. So I'm going to put the 444.44 on top, and I'm going to put the 333.33 on the bottom. Setup's all done. I punch all this in. 1250 multiplied by 261.15, divide that by 334.26, multiplied by 444.44, and divide by 333.33. I'm getting a final volume of 1302 in my calculator. However, we can only have 3 sig figs. So we can't leave it as 1302. And actually, we can't leave it as 1300 either, because that would only be 2 sig figs. So the only possible way we can show this answer appropriately is by using scientific notation. So we have to change that 1300 into scientific notation with 3 sig figs. This is going to end up being 1.30 times 10 to the third. That's 3 sig figs. That shows 1300. And our label on that's going to be milliliters. That's all I've got for the 30s. Some of these other problems, as you keep going further, are going to have the moles as a part of the factors, as the variables that are going to be changing the math. So if you know the relationships between moles and volume and moles and temperature and moles and pressure, you should be okay. It's going to be similar types of problems.